For the entirety of 2023, the progress made in the AI section is tremendous. But near the end of 2023, AI has been put in the focus once more with the release of Intel Core Ultra with the new Meteor Lake architecture, specifically on-device AI. This distinction is important because currently ChatGPT, Google Bard, or even Microsoft Copilot is all processed on the server side. That means we need to be connected to the internet at all times so that our prompts to those AI chatbots will be processed and then the answer is sent back to us from those servers. The new Intel Core Ultra processor has a built-in neural processing unit, or NPU for short, and that will process all of our prompts locally on our device without the need to be connected to the internet. I'm sure many people have a lot of questions, so let's go through all of them in this video. Having an NPU in your device is actually not new. Phones have a built-in NPU chip for many years right now, and even AMD has an NPU built into their SoCs as well. But my biggest question is, how's the new Meteor Lake processor? Honestly, I had the same question too. The new Intel Core Ultra series of SoCs are using the new Meteor Lake architecture, and one of the laptops that were announced alongside with the arrival of Meteor Lake SoCs is this ASUS ZenBook 14 OLED UX3405MA, which is powered by the latest Intel Core Ultra 7 155H SoC. From the list of SKUs provided by Intel, it seems like every single SoC that is based on the Meteor Lake architecture will have the same Intel AI Boost neural processor. So I decided to do a few benchmarks of my own. I did Geekbench at first, but it seems like the results are kind of inconclusive. I needed more freedom to control some of the parameters. So I used UL Procyon. Procyon? I don't know how is it pronounced, but Procyon. This benchmark tools has a lot of different parameters that I can actually play around with, and so the benchmarks began. First, we have to select what API to use. There are two main ones to choose from, Windows ML or Intel's OpenVINO. Windows ML is an API built directly into Windows 11 and it is open to any hardware maker or software programmer to use. You might have heard the name DirectML before, but that is a component that is built under Windows Machine Learning umbrella. Intel's OpenVINO is an API developed by Intel, obviously, but this API is made specifically to work better with Intel's own hardware. So let's compare the AI inferencing performance using the CPU with different APIs first. As we can see here, OpenVINO performs a lot better than Windows ML. And now let's switch gears to the GPU. This time OpenVINO doubles the performance of Windows ML, which is actually surprising to see how well OpenVINO is optimized for their own hardware. Okay, remember that the Meteor Lake SoCs has a built-in NPU? Yeah, unfortunately we cannot use the NPU with Windows ML, so we cannot compare the performance difference. But as we can see here, the performance of that NPU is 4 times better than the CPU using OpenVINO. And in terms of raw AI performance, the GPU is gonna be the best. And then comes the NPU and lastly the CPU. My next big concern is power consumption. How do they vary? Is the NPU the perfect choice for both speed and power efficiency? Well, I redid the test using OpenVINO only, and these are the graphs that we got. Those dips are because one test ended and the next test is loading, and seeing only the CPU's graph here, we can see that both the power consumption and temperature has a lot of spikes, and it takes around 21 minutes to complete the benchmark. Switching over to the GPU, it doesn't have extreme spikes like the CPU does and takes less time to complete the test, about 20 minutes or so, which is still an improvement over the CPU. Now it's time for the star of the show, the NPU. The power draw is significantly lower and the temperature seems to be lower as well. However, it takes nearly 25 minutes to complete the benchmark. I then recompile all of these graphs, and the first one is this, the average power consumption. From the data that we have gathered, we can see that the NPU is the most efficient out of the three, and then comes the GPU, and finally the CPU. What about the average temperature then? Surprisingly, they are all pretty close in terms of average temperature. Once again, the NPU is the most efficient, then comes the GPU, and finally is the CPU. And so the conclusion is, for Meteor Lake architecture in particular, we can say that all AI inferencing tests using NPU is always the best choice. However, if you need something to be processed as fast as possible, then use the GPU, but at the expense of power consumption. And try to not use the CPU to do any AI tests because it's the slowest and also the least efficient out of the three. But why? Why have an NPU in your device? Well, the simplest answer is to run all of the AI tasks locally on your device. There are actually a lot of benefits from doing this. The most obvious is that we don't need an internet connection when we want to do anything AI related. Even the most remote corners of the earth, we can still use our AI tools. And since we don't have to send our data back to the server to be processed, our privacy is also protected. I'm sure many of you have seen headlines of how many companies are banning their employees from using ChatGPT because of data and security concerns. And since we don't need to have an internet connection, we might be more energy efficient as well. I don't have the exact numbers to compare though, but it should be more efficient. However, readily available AI tools that run locally on our devices are still scarce, I would say. We do have Stable Diffusion Web UI by Automatic 1111 and GIMP with Stable Diffusion built in, but setting them up isn't exactly user-friendly, I would say. I do think that since we have the hardware readily available right now, more software that runs AI locally will start to appear real soon. Perhaps even ChatGPT or Copilot will move on to run locally on our devices so that these companies can save on server costs and also be more efficient at the same time. And we don't have to worry about our data getting used to help build their own data set. And that is all we have to share with you in today's video about AI and Meteor Lake processors specifically. Do let us know what you think about Intel's Meteor Lake SoCs and also the new NPUs. And also, the Meteor Lake SoCs do come with a new integrated Intel Arc GPU architecture as well. So if you want to know more about the graphics performance in games, then do click at the top right corner there to watch it, or at the end screen here. And same goes to the review of this laptop. It's a beautiful laptop, honestly. Check those videos out and do remember to subscribe and like this video. We'll see you guys in the next video.